Sabi Africa. No Africa. No Africans. Pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
Healing with bark, phytochemistry in traditional medicine. Do you know how a tree's bark, the living skin that guards it, stores powerful chemistry honed by evolution? Today we will travel from village knowledge to laboratory benches, following the molecules, methods, and stories that make healing with bark a frontier of African science and global health. Bark is not just inert wrapping, it is a dynamic defensive organ rich in terpenes, polyphenols, tannins, and sometimes rare alkaloids. Because these metabolites protect the tree from microbes, insects, and herbivores, they are often lipophilic, polymeric, and structurally diverse. That makes bark a unique chemical reservoir, a place where high-potency scaffolds concentrate and where multi-target pharmacology naturally emerges. In short, bark gives us chemistry that often cannot be found elsewhere in the plant. In southern Africa, the pepperbark trees of the Warburgia group have been used for fevers and infections for generations. Chemical analysis reveals drymain-type sesquiterpenes, dialdehyde scaffolds such as warburganol, polygodial, and mucaadial, and molecules with striking antimicrobial and antiparasitic action. Laboratory isolation and in vivo studies have confirmed potent antimalarial and broad antimicrobial effects for these compounds, explaining the ethnomedical uses and pointing to new lead scaffolds for drug discovery. Prunus africana, the African cherry, illustrates both promise and peril. Its stem bark contains phytosterols, pentacyclic triterpenoids, and phenolic esters that modulate inflammation and prostate physiology, matching traditional uses for urinary and reproductive complaints. But high demand for bark led to overharvesting, ecosystem risk, and urgent conservation responses. This species teaches us that scientific promise must be matched with sustainable management. Across West and Central Africa, Alconia cordifolia is a go-to remedy for wounds, infections, and liver complaints. Modern phytochemical profiling finds flavonoids, phenolic acids, tannins, and alkaloids, a mix that explains antioxidant, anti-inflammatory, and hepatoprotective activity observed in vitro and in animal models. Importantly, these are not single magic bullets, but ensembles of moderate potency molecules working together. In technical terms, bark therapies often act via polypharmacology, which is multiple compounds interacting with multiple human and microbial targets. That raises two research priorities. One, chemical fingerprinting, robust LC-MS-NMR profiles and marker compounds to ensure reproducibility, and two, mechanistic mapping, where network pharmacology and pathway assays are used to understand how compound ensembles modulate inflammation, oxidative stress, and infection. These methods allow us to respect traditional extract forms while delivering modern reproducibility. Natural does not mean risk-free. Some bark constituents are cytotoxic at elevated doses. Traditional preparation methods like decoctions, dilution, and topical formulations often lower risk and were developed as practical safety steps. Modern development must pair efficacy screens with full toxicology, acute, subchronic, and genotoxicity, and examine traditional preparation as testable strategies that may reduce toxicity or improve bioavailability. Turning bark chemistry into products must not repeat colonial extractive patterns. The Nagoya Protocol provides legal and ethical scaffolding for access and benefit sharing. Case studies in Prunus Africana show how community agreements and sustainable harvest protocols can reduce overexploitation while keeping value local. The scientific pathway must therefore be co-designed with custodial communities, tied to forest stewardship, and structured so that benefits like training, revenue, and reinvestment flow back to those who steward the knowledge and the trees. A realistic roadmap: start with community-led bioprospecting that documents dosage traditions and consent. Move samples into regional phytochemical hubs for LC-MS, NMR fingerprinting and safety screens. Develop 2 parallel product streams: standardized whole extracts for symptom-based regulated market entry and purified leads for clinical development, and bind it all to certified sustainable harvesting and benefit sharing. This creates jobs, keeps intellectual value local, and aligns ecology with industry. Here's the human bit. Barks are not raw commodities, they are storied medicines shaped by generations. When scientists, healers, and communities work as equals, pairing rigorous phytochemistry with conservation and fair economics, we do more than discover medicines. We rewrite the narrative. Africa as a knowledge engine, stewarding ethical, high-value health innovation. If you are a researcher, policymaker, or funder, ask who is at the table. If you are a viewer, share this story. The chemistry is in the bark. The future is in how we choose to use it. Like this video, share your thoughts, and subscribe for more deep dives into global history and science.